Hi, and welcome to our discussion on atmospheric dynamics. We are working our way through unbalanced flows right now. And our last topic in unbalanced flows is geostrophic adjustment. So geostrophic adjustment is when the wind becomes geostrophic. How do they become geostrophic? Well, through a process called geostrophic adjustment, and this is where an unbalanced atmospheric flow is modified into geostrophic equilibrium. Now, the way this occurs is that, well, initially you see here, you have an arrow that represents the wind, and you're looking down on a weather map with lower heights to the north and higher heights to the south. So if the wind was perfectly geostrophic, it would be blowing from the west to the east parallel to these contours. But it's out of balance. It's going across the contours. So if it's going across the contours, that means that it's accelerating. As it accelerates, the Coriolis force increases. Remember, Coriolis is a function of the wind speed. So initially, when the wind speed is low, Coriolis is small, pressure gradient is bigger than Coriolis, and it's pulling it towards lower heights. But as the wind speeds up, Coriolis gets bigger, and eventually Coriolis will equal pressure gradient when everything is in perfect balance. In other words, Coriolis is strong because the wind speed accelerated, and it perfectly balances pressure gradient force. And if the wind can be thought of as like a ball rolling down a hill, it starts to accelerate and it has momentum. If it starts going up a hill, it still has momentum to get over the hill. So similarly, the wind starts to accelerate towards lower heights. Eventually, there is momentary balance where pressure gradient force is greater than or is equal to Coriolis force. But then the wind continues to accelerate a little bit. It starts to slow down, but it was moving pretty fast. It has momentum, so that slight increase in the wind speed results in a higher Coriolis force. And that will pull it back to the higher heights. So as it goes uphill, it starts to slow down. As it goes towards higher heights, it starts to slow down, and Coriolis force becomes smaller. And as a result, it will start to flow back towards lower heights. So in other words, you have this constantly seeking a balance. The wind constantly tries to seek a balance. Starts flowing towards lower heights, it accelerates, Coriolis force gets bigger, there's momentary balance, but there is momentum and the wind is a little bit stronger, so Coriolis force is a little bit bigger, that pulls it back to higher heights. And this keeps going on, back and forth, until finally there is a balance. So this takes some time. And you'll see this on weather charts. You see that the pressure gradient is tighter in some locations and weaker in other. That means that there is a response by the wind to this pressure gradient. So it's accelerating and decelerating, and it's going back and forth trying to seek balance. The balance occurs after a period of time, and that time depends upon the Coriolis force. If the Coriolis force is very strong, such as at high latitudes, if you're talking about the Arctic, then that balance occurs pretty quickly because Coriolis is pretty strong. But at the equator, where there is virtually no Coriolis force, or in the tropics, that balance occurs a lot slower. It might take more like a week because of the weak Coriolis force. So that's kind of an overview of how winds become geostrophic. Hope you enjoyed it.